Okay, I'm going to go over number 1 and 2 on the Chapter 3 Version 1 test. So in the question number 1, we're given a proof and we are told that angle 1 and angle 4 are congruent. So I'll go ahead and mark those on my diagram. And I'm going to go ahead and fill that in as my given information. And eventually we've got to prove that angle 4 is congruent to angle 3. Okay. The second step is given to you, at least the statement is, that AE is parallel to CB. So I'm going to mark that on my diagram. And why would we know that? Well, if we go back to the first statement, which was angle 1 equals angle 4, and we consider these parallel lines, CB and AE, and then CD is our transversal, we can see that 1 and 4 are in the same spot. So we call those angles corresponding. And we know from our list of ways to make lines parallel in a proof that corresponding angles being congruent is one way to prove that lines are parallel. Next, we're told that angle 2 is congruent to angle 3. So I'm going to go ahead and mark angle 2 congruent to angle 3. And again, we are looking at two angles that are making an angle with, let's see, AB. So we'll call AB our transversal, and then CB and AE are parallel lines. 2 and 3 are on opposite sides of the transversal, but inside the parallel line. So we call those alternate interior angles, and we know that they're congruent if the lines are parallel. We've already established that the lines are parallel, so I can put that kind of in my if statement, and then I'll call these alternate interior angles, which should be congruent. Alright, step 4 was a given, so let's go back, and I have not put this information in yet. AE bisects angle DAB. Alright, after that statement, typically what you're going to see are two angles that are congruent to one another. So let's see, DAB is here, and it's composed of angle 1 and 2. So it turns out that angle 1 is congruent to angle 2. So I'm just going to add an extra congruence symbol here on the 1, so now that 1 and 2 look the same. And I'm going to write angle 1 is congruent to angle 2. And I'm going to provide this reason, the definition of angle bisector. There's no 1/2, so it's not angle bisector theorem. Just by definition of angle bisector, if an angle is bisected, then the two angles composed in the larger angle are congruent to one another. Alright, finally, I know I'm supposed to prove that angle 4 is congruent to angle 3. Now, how would I know that? Well, I used to know that 1 was equal to 4. Then I figured out that 2 equaled 3. Then we figured out that 1 equaled 2. But go back here, 1 did equal 4, so I can actually add an angle marker there, congruence marker there. And I'm using previous information, just setting it up in different ways, so I can call that substitution or transitive. Either would be acceptable. Okay. Next proof, a little shorter. We are told and are given that F is congruent to J, so I can write that as given. We're told that GHF is congruent to KHJ, and we recognize that very well. We've seen this X so many times. When two segments or lines or rays cross one another like that, they create two congruent angles, and we call those pairs of angles vertical angles, and so our reason is going to be vertical angles are congruent. And then finally, I'm supposed to prove that angle G is congruent to angle K. Now, why would I know that? Well, let's take a look. We've got two triangles going on. We've got this triangle on top put that in blue, and then let's try this yellow for the bottom triangle. Okay. And I know that this angle equals this angle, and then these two angles are equal, and I know that a triangle sums to 180, so if these two sum the same and these two sum the same, then the amount that I have left as far as degrees in the triangle should be the same. So that was a corollary of the triangle sum theorem, if you recall from section 3.4. And it went something like this. If two angles of one triangle are congruent to two angles of a second triangle, I think I had to abbreviate it this way. Two angles of two triangles are congruent, then we know that the third angles are congruent. That concludes this session.